Now let's draw the supply curve by hand. So this is like in Uwe Reinhardt's New York Times article, or in I believe it's chapter 4 of the book on principles of economic evaluation. It's also similar to what I showed you how to do in triage. So a supply curve looks like this. So you're choosing between, two drugs or two policies or two options, choosing between two things, two health interventions. And they each have a cost in dollars and then an effectiveness in qualities or quality adjusted life years associated with them. So let's say here that option A, drug A costs $75,000, drug B costs $165,000. Drug A gives you 2 quality adjusted life years and drug B gives you 5 quality adjusted life years. And what we need to do is analyze the supply curve to decide whether or not it's cost effective to scale up the supply curve and switch from drug A to drug B. So drug A is, the drug we're already using, or that's the comparison group, or something that's already on the market. And now there's a new one, drug B, and we have to decide whether drug B is cost effective compared to A. So the first thing we do is we look at the slope of the supply curve. What's the slope of that line? It's the change in Y over change in X, change in cost over the change in quality, the rise over the run. So just the incremental cost effectiveness ratio of B, the ICER of B, that's the cost increment of B, so the cost of B minus the cost of A. And take that quantity divided by the effectiveness increment, the incremental effectiveness, the quality of B minus the quality of A. Now what does this come out to? Well, the ICER of B, in this case, it's got to be a cost per quality. So the ICER here comes out to $30,000 per quality. So if you solve that second line of the equations there, it's $30,000 per Q. $30,000 for one quality adjusted life year, for one quality. $30,000 per quality, that's the slope of that supply curve to the left. And then the other parameter is, remember in triage we set willingness to pay equals $50,000. This is the society's value for health, society's willingness to pay for one quality adjusted life year. This is the dollar value of 1 year of perfect health that they talk about in some of the readings. And now the main decision rule is that if the ICER of B is less than willingness to pay, we choose B. So in this case, that's true, right? The ICER of B is $30,000 per quality. That's less than the willingness to pay, which is $50,000 per quality. 30,000 is less than 50,000, so we're going to choose B. So we'll scale up the supply curve and choose drug B because drug B is cost effective compared to drug A. The additional cost of drug B is worth it given that additional effectiveness, those additional quality adjusted life years we get for drug B. Now, the other quantity you'll see in the triage examples is the net monetary benefit. So net monetary benefit is always equal to the quantity of the quality adjusted life year times the willingness to pay minus the cost. So what the net monetary benefit does is it uses that willingness to pay to convert the cost and the quality of A into just a single measure, single number. So what's the net monetary benefit of A? Well, it's the effectiveness of A, that's 2 qualities, times the willingness to pay, and remember we said that's $50,000. We let willingness to pay equal $50,000. And remember, willingness to pay is something that we as a society have to decide how much we value a perfect year of health, how much we'll pay for one quality adjusted life year. So 2 qualities times $50,000 per quality, those quality units cancel there. So when we subtract the cost, the units will just be dollars minus dollars, and the net monetary benefit will be in dollar terms because it's monetary benefit. And what does this come out to? Well, 2 times $50,000, that's $100,000 minus $75,000, that's going to be $25,000. So the net monetary benefit of drug A is $25,000. Remember, net monetary benefits are just in dollar terms. And then we'll do the same thing for drug B. So what's the net monetary benefit of drug B? Well, that's going to be the quality adjusted life years associated with drug B, quality subscript B, times willingness to pay, WTP minus cost subscript B. Remember, the qualities will just cancel, and then the units will be dollars minus dollars and end up in net monetary benefit of drug B. So remember, you can see in the graph that we said drug B has 5 qualities, 5 Qs associated with it. The willingness to pay, we just let that equal $50,000 per quality. That's sort of a convention, society's dollar value of a year of life. Subtract the cost of B, we said B costs $165,000. So what's that going to be? 5 times 50,000. That's going to be $250,000 minus $165,000. It's going to be $85,000. So the net monetary benefit of drug B is going to be $85,000. And now we have, we're going to end up making the same decision that we did when we just compared the ICER to the willingness to pay. Remember, we said if the ICER sub B is less than willingness to pay, we choose B. The other thing we'll say is if the net monetary benefit of B is greater, the net monetary benefit of B is greater than the net monetary benefit of A, we choose the one with the higher net monetary benefit. If B has a higher net monetary benefit, then we choose B. And that's equivalent to that ICER sub B less than willingness to pay. So we have 2 sort of decision rules that are going to give you the same result, that drug B is cost effective compared to drug A, that we should scale up the supply curve from drug A to drug B and choose drug B.